All right, boys, in this video, we're going to be looking at ratios, okay? So understanding ratios using the learning goals here that you'll need to know. So firstly, that ratios represent qualities, okay, expressed in the same units. So they're not written, so we don't write the units, but we express it in the same units. And also you are able to write ratios and create equivalent ratios. So we're going to get into that too. So there's two parts to this lesson. So make sure you're watching to the end and you're taking notes. So generally though, when do we see ratios? So we use ratios in everyday life all the time. So we've got 5 key times where we sort of see ratios, and that sort of include definitely in ingredients. So when you're cooking, use a ratio of ingredients, okay? So 1 part sugar, 2 parts salt, etc., something like that. We definitely see them in maps, and most maps include a scale, which is written as a ratio. We'll explore what that looks like. Now, one key one is you see it all the time in sports. So if you've got a win to loss ratio, you've got a team's win-loss to their ratio of wins, sorry, to the ratio of their losses. We see in comparing size, particularly with length, 1 centimeter ratio to 1 meter, etc. And also some particularly legal requirements. You hear this word all the time, like staff to student ratios, etc. So let's get into the nitty-gritty of it here, and here are some keynotes that I'm going to need you guys to take down. And it's firstly that ratios show the relationship between 2 or more related quantities. So it's important that you write that down. So example, and one we see often all the time, is when we're talking about cordial, you might have the ratio of cordial to 1:3. So if this is our cup here, you might put 1, okay, of concentrated cordial to 3 parts sort of water, and that's a ratio to creating cordial. So the colon, which is the symbol here, so the 2 dots on top of each other, it's the mathematical symbol used to represent ratios. And what that means, or what that term means, is can often be read as either, we're using this example, A is to B, it could be as A to B, or can be also read as A is to B. So that's how you sort of talk about that scenario, etc. Also, it's very important that you understand the order in which the quantities are written is very important. So if we use that example previously about sporting success, if you have 5 is to 2, is you need to understand that that's 5 wins is to 2. If you had that other way around, it would be losses to wins. So very important that you understand the way the ratios are written. And finally, before ratios can be written and simplified, the quantities must be expressed in the same unit. Key point there that, again, I'm going to get you to write down. So you need to make sure that they're on the same unit for you to write down those ratios. So we've got 3 questions here we'll quickly look through, and then we'll move on to the next part. So the first one is here, simply writing some ratios. We've got 5 cashews, 12 peanuts, and 2 macadamia nuts. If you had to write the ratio of cashews to peanuts to macadamias, so simply just writing it as we've got 5 cashews is to peanuts, which is 12, which is to macadamias, which is 2. So you simply write it like that using that symbol. The ratio of cashews to the total number of nuts. So I know that I've got 5, and total I've got 12 plus 2 plus 5 is to 19. So I've got 5 is to 19. And finally, the ratios of peanuts to the other nuts. Okay, so I've got 12 peanuts, and in total, the rest will be 5 plus 2 is 7. So see how that helps us with the order. As long as you understand the order, you can move on from there. Now we've got to be able to also create equivalent ratios. So you notice that this is very similar to how we've been doing our fractions or understanding our fractions, and we do it in a similar way. But for the important key here is that for each value in a ratio is multiplied or divided by the same number, an equivalent ratio is formed. So for example, if we have 1 is to 3, that's the same as saying 2 is to 6 or 10 is to 3. See, we've sort of, in this case, we've doubled it. In this case, we've timed it here by 5. So creating an equivalent fraction still means the same thing. We've just created an equivalent ratio, sorry, I should say. So understanding that, and then we can also understand how we can simplify ratios. So we've got 2 questions here. Complete each pair of ratios. So if we have 4 is to 9, I'll get you to write it down like so. So if we have 4 is to 9 and we create 16, okay, so you draw the arrow down there, we create 16, you draw the line down there. What you're doing to both sides is that you are timesing it by 4, sorry. So if you times that by 4, you need to make sure you times this side by 4 as well. So 9 times 4 is 36. And we're also going to do the same in this case here for dividing by. So we've got the ratio of 30 is to 15. And and we know that we break this down to 5. So in this case, I'm dividing both sides by 3. Okay, and that will give me the new equivalent ratio of 10 is to 5. So make sure you understand those two things. A, what ratios are, the key parts of that, also how to create or understand equivalent ratios, and also opportunities of where we see ratios all in everyday life. So make sure you're taking all those notes and ask any questions you guys have in class. Thanks, boys.